Okay, so we're talking about exponential functions today. You should have talked about exponential functions in Math 1 and in Math 3. So we're just going to do a quick rundown of what you hopefully already know. So an exponential function is a function in the form y equals a times b to the x. So A tells you your y-intercept, and B is your rate, whether it be growth or decay. So let's look at if it's growth or decay. Okay. So a growth graph could look something like this. And a decay might look like this. So you read a graph, hopefully you remember, left to right. So if we read our growth, we're starting low, and we're growing and growing and we're growing. And then decay, we're starting high, we're decaying, we're decaying, we're decaying. So if you look at these, when we talked about like domain and range, we just assumed that the arrows meant they went forever in both directions. But let's look at a growth graph. So let's say we had 2 to the x. And so we know it's going to be growing because 2 is greater than 1, which we'll write down here in a second. But if we look at the graph, here it is. So it looks like it's just going to keep going and then just keep going down into the negatives. But if you look at the table, hold on. If you look at the table, we see as our x's are getting bigger, our y's are getting bigger, which means it's growing. But if we go down to our negative y, look what happens with the y's. So they're just getting smaller and smaller and smaller and smaller decimals. So an exponential equation or function has what's called an asymptote. So it'll get really, 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 really close, but it'll never touch it, it'll never cross it. So for this one, that is at 0. So it's going to get super close to 0, but it's never going to equal 0 or negative. So it's growth if b is greater than 1, and it's decay if b is less than 1. And less than 1 as in a fraction or decimal, not a negative. That's something different. And then for growth, if you're talking about a rate, which we'll talk more tomorrow, then the growth is 1 plus the percentage, and decay is 1 minus the percentage. And of course you always want your percentages as decimals. And then A, like I said, is your y-intercept. So let's do some. So this we want to know, are the following growth or decay, and what is the rate or percent? So let's say we have y equals 1/2 times 2 to the x. So would this one be growth or decay? Growth, how you know? Good. So 2 is our b value, and that's greater than 1. So then it is growth. And that's again because our b equals 2. Now if we wanted to know this rate as a percent, since it's growth, it's got to be 1 plus something. Well, 1 plus what gives me 2? 1 plus 1. What is 1 as a percentage? 100. Good. So then our percent would be 100%. And like I said, we'll look a little bit more at that kind of stuff tomorrow. Let's do one more. Let's say we had y equals 0.3 to the x. Good. Decay, how you know? Good, because our b is 0.3 and that's less than 1. Good. So then if it's decay, that means for our percentage, we have to have 1 minus something. So 1 minus what would give me 0.3? Good, 0.7, which is 70%. Good. Questions? Alright, so something else that you should have done is transformations. Now you might not have done transformations specifically with exponentials, but the rules apply to all of them. So whether it's a quadratic or a radical, the rules are still the same. So we have y equals a times b to the x minus h in the parentheses, and then plus k at the end. Okay. So our exponent here, x minus h, that tells you if you're taking your graph and you're moving it left or right. So if you have x minus h, then you're moving to the right. If you have x plus h, you're moving to the left. And then the k tells you up or down. So if it's plus k, you're moving up. Minus k, you're moving down. Okay. So then the other thing we have to think about is if it has any reflections or not. So if you have a negative a, okay, so a negative a means you want to reflect over the x-axis. And then the other one, it could be a negative x. It could also look like negative in front of the parentheses. So either one, whether it's just a negative x or whether you have a negative out front, but either way that negative is in the exponent. And so that's a reflect over the y-axis. And again, these are the same rules as if it were a quadratic or a radical or whatever. Okay. So let's do some. So let's describe the transformation. So let's say our first one is y equals 3 to the x plus 1 in the exponent. So how does that one move if it's plus 1? Good, left. So that one would go left 1. Good. How about if we had y equals 3 to the x and a big plus 1? Yeah, up. Good. So up 1. Good. How about if we had y equals 3 to the negative x? Good. So that's going to be a reflection over the y. Good. Alright, one more. Let's say we have y equals negative 3 to the x. Good. So that's a reflect over x. Okay. And so you might say, well, what does that look like? So if we graphed our original 3 to the x, and then we graph negative 3 to the x, there's our first one, and then there's the second. So again, when you reflect, you're just taking it, kind of laying it over the x-axis a little bit. And then for the one before, if we have negative x in the exponent, again, there's our first one, and then there's the second one, maybe. There it is. Okay. Any questions about transformations? Alright, so then the last thing we're going to do is write an equation. Yeah. Mm-hmm. You can go, if you go beside where the y equals is, you can change it. So you can make it bold, you can make it, let's see if it's an inequality. Yeah, you can change those options. Okay. So now we want to find an equation for the following. So let's say we had a graph. So we have our y-intercept at 1, and then that point is at 3, 8. Okay, so you can solve these by hand, but we have our friendly calculators that will help us do this. So what you want to do when you're finding an equation is have 2 points. So we know this top point here is at 3, 8. What are the coordinates of my y-intercept? 0, 1. Good. So remember, y-intercept, your x is always 0. So those are our 2 points. So what you want to do is type these in. So you want to go to stat, which is right beside the arrow, same stat we were using for all of our stats stuff, and hit enter. And then you want to make sure that it says L1 and L2. If it doesn't, you need to reset your calculator. So in L1, we're going to put our x values. So I have 0 and 3. And in L2, you put your y's. So 1 and 8. And then we go stat, calc. And this is exponential. So if you scroll down to number 0, it says exp reg. So that's exponential regression. So that's what we want. You want to make sure that this says L1 and L2, which it should unless you change it, so don't. And then you hit enter. And there it is. So it tells us our A is 1 and our B is 2. So y equals 1 times 2 to the x. Any questions? Yeah, so you go to stat, hit enter, type your points in. And then you go back to stat, over to calc, and down to number 0. Enter, 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 enter. There you go. So let's write those out. So you go to stat. You go, or you hit enter. And then in L1, you put your x's. In L2, you put your y's. Then you go back to stat, over to calc, and then you want number 0, which says exp reg. So exponential regression. All right, let's do one more. So what are my 2 points here? So I got 0, 1 again. Good. And -2, 2. So we type them in. So again, we go to stat, we hit enter. You can clear out what's there by hitting clear and enter. Do not hit delete. So x's go in L1, y's in L2, and then stat, calc, 0, and there it is. So again, 1 is our y-intercept, which we could have got that from our graph. And then our rate's at about 0.71 to the x. questions.